Hello everyone, my name is Aaron Martin, and today I'll be presenting a study on defect detection in the presence of geometrical artifacts. This study focuses on separating real defect signals from artifacts created by the geometry of a part. And this study also explores true defect signals even when images may contain many artifacts caused by different complex and component geometry. The goal of this study is to distinguish real defects from noise and structural artifacts. The methodology of this study is that they collected full matrix data and generated multiple different views from different people and used this as a total focus method. The researchers scanned a pristine sample 100 times to understand the intensity at each pixel. Ultrasonic phased array data collected using full matrix capture, and multiple views generated using total focusing method, as I brought up earlier. And also the pristine sample was scanned 100 times to find out intensities throughout these pixels. The type of analysis is defect detection is treated as a hypothesis test. For each pixel, they would calculate a p-value based on a certain model, and low p-values indicate a likely defect. Defect detection was framed as hypothesis testing, and p-values computed per pixel on fitted Gaussian distributions. ROC curves were also used to compare detection performance across multiple views as well. The fusion of results using Fisher's method also improved the detection throughout this study. The key findings that I found in this article was 1. Pixel intensities as non-defective samples fit Gaussian models well. Low p-values reliably indicate true defects throughout this study. This method performs nearly as well as ideal conditions with no artifacts, which I found really interesting. My reflections and my conclusions in this article my reflection would be it helped me understand how statistical modeling solves these different problems throughout a study like this, because I didn't really follow or know much about this article or this concept and this topic, but after reading it, it really helped me understand that. It also showed real world use of hypothesis testing and probability distributions, which I had seen in many different articles, but when I looked at this one, it was very interesting and it helped me understand more. My conclusions would be that statistical tools enhance defect detection even in challenging imagining conditions. And it demonstrates the power of combining engineering and statistics, which I've never been much of an engineering person, but when I look at this, it's refreshing to know and see that engineering and all that could be used in many different places, and I found this article was very intriguing, and I really enjoyed doing a PowerPoint on it today. Thank you.